Hi everyone, today's SOS video is for Unit 5, Lesson 2. The main concept of today's lesson was solving compound inequalities, which are inequalities that satisfy two or more given conditions. The solution sets can be graphed on a number line, or they can be expressed using what we call interval notation. Compound inequalities are inequalities that are joined by the word and or the word or. Today we're going to focus on the compound inequalities joined by the word and. The solution set to the inequality is all numbers that make the inequality a true statement. The procedure we're going to use to solve the compound inequalities joined by the word and are as follows. The first step is to graph each inequality separately on a number line. We're going to identify the parts on the number line where the two graphs overlap, because this is the solution set to the compound inequality. Then we're going to make a graph on a new number line to show the solution set, or we're going to use interval notation to represent the solution set. Let's take a look at the first example. We want to graph the solution set to x is less than 8 and x is greater than or equal to 2. After we graph the solution set, we're going to use interval notation to represent the solution set as well. So to graph x is less than 8, so to graph x is less than 8, we are going to put an open circle over the 8 and draw an arrow that goes to the left. For x is greater than or equal to 2, we have a colored in circle over the 2, and we draw an arrow going to the right. Now we want to look to see where the two graphs overlap, and that would be from here to here. Okay, so on our second graph, we're going to make a final graph, which is just the portion where these two graphs overlap. So we have a colored in circle over the 2, open circle over the 8, and then all the points in between, and that is the graph of the solution set to this compound inequality. How would we represent the solution set using interval notation? Well, we know that the solution set goes from 2 to 8. We know that we can include the 2, that's what the colored in circle represents, so we use a bracket to show that we can include the 2, and because we cannot include the 8, we represent that with a parenthesis. So using interval notation, we have bracket 2 comma 8 and then close with the parenthesis. For the next problem, we're going to graph the solution set to the compound inequality, and this we can read from the middle out. So this I would read as x is greater than 3 and x is less than 10. So now I'm going to graph each inequality separately on the number line. So x is greater than 3 would be an open circle over the 3 with an arrow to the right. X is less than 10 would be an open circle over the 10 with an arrow going to the left. And then we're looking to see where the two overlap. Let me extend this a little bit more so that you can see that the two graphs are going to overlap right here. So that would have an open circle over the 3, open circle over the 10, and then we connect the 2. So our solution set would be all the numbers that are in between 3 and 10. Using interval notation, we have the numbers that go from 3 to 10. We can't include the 3 or the 10, so we use a set of parentheses. All right, why don't you try the next one on your own and come back and check to see how you did. All right, let's see how you did. Before we could graph the solution sets to the inequalities, we actually had to solve both of these inequalities. So for the first one, 3x plus 2 is less than 26. Subtract 2 from both sides, then divide both sides by 3. We get x is less than 8. For this inequality here, subtract 4 from both sides, divide both sides by 2. We get x is greater than or equal to negative 1. So we're graphing the inequality. X is less than 8. And x is greater than or equal to negative 1. For x is less than 8, we use an open circle over the 8, and the arrow goes to the left. X is greater than or equal to negative 1 is a closed circle over the negative 1, and we draw an arrow to the right, looking to see where these overlap. Would be a colored in circle over the negative 1, open circle over the 8, and all the points in between. All right, using interval notation, we could write here, the solution set would be from negative 1 to 8. We include the negative 1, but we cannot include the 8. So there's our solution in interval notation. One thing I want to add as well is if when you graph your inequalities, if you do not have a section on the graph where the two inequalities overlap, then there would be no solution to the compound inequality. You might want to jot that down as well to add to today's SOS worksheet. Thanks for tuning in to another SOS video lesson.